Welcome to Command Shift Left, the podcast that helps you navigate the treacherous waters of the software development, ops, and security world while also diving into the hot current trends in the industry. Join myself, developer Philip, our co-host or Vice.
Hey audience!
As we battle through hilarious real-world stories, pro tips and hacks for navigating your way around developer security, learning about our Shift Left life, and life stories that have saved our ass. It's an absolute pleasure to have two incredible guests with us today. We have Reese and Oded. Thanks for coming. And in no particular order, why don't you guys introduce yourself, and let's start with Reese.
Thanks, Philip. Hi, everybody. My name is Reese Arkins. I'm an Australian based in Stockholm in Sweden, and I'm currently working as the VP Product Management at Mend.io.
You want to add a few words about what Mend is?
I'd love to. Thanks. So Mend, at Mend, we focus on application security. We came from a background of open source security and license management. And I guess the way I came to Mend was about 7 years ago, I scratched an itch and built an open source tool called RenovateBot as an open source tool to automate the updating of open source dependencies. And about 5 years ago, I decided that it would make a lot of sense to join a bit bigger startup than just myself. And that's how I came to be at Mend. And happy to say I still get to work on open source and RenovateBot until today.
That's awesome.
Amazing. It's great to have you here. And Oded?
Thanks.
Hey, everybody. So my name is Oded Ben David. I'm currently the first developer at Permit.io, and I also leading the R&D here. Previously, I also was part of core teams at startups like Clarity and Visible Risk. I really love developing and creating cool application for my family, for my friends, for everyday life. And that's it. I'm really happy to be here today.
Excited to have you. And I think this is a perfect point to jump into the show itself with our first fact for this episode. And that fact belongs to me.
So, Or, take it away.
So my fact for this episode is that many developers are confused by Slack's API for confirming incoming messages. Their docs read the following. Your app should respond to the event request with an HTTP 200 within 3 seconds. If it does not, we'll consider the event delivery attempt failed, and after failure, we'll retry 3 times, backing off exponentially. And what I saw multiple developers work with that feature, and they just didn't notice that aspect of the software exists. So they kept getting retransmissions on their messages because they didn't reply to them. They didn't return that 200 okay, and they had duplicates of their messages. And I saw that multiple times, and I think the reason for this is that, people don't really read docs as we expect them to, and they especially don't read the fine print. They're like, how do I use this? Okay, it works. I'm going to stop reading the docs. I'm going to drop it here. It's good enough for me. I don't need all the fine print. I'm a good developer. I know what I'm doing. And I want to ask you folks, first of all, if you've encountered this situation building with Slack or with maybe other solutions where you skip the docs, and what do you think we should do to make sure people actually get the important notes that we try to push in our docs?
So now I know why I was getting duplicate messages when I was testing this and couldn't figure it out. But surely when you mention fine print, is that really fine print, or is it just another paragraph that people just
it's another paragraph.
Okay.
It actually appears in 3 paragraphs.
All right.
And there's 1 paragraph that is dedicated to this, but they all appear down the line. Like here's how you call the API, and then there's a bunch of other things that you should know. Some of them related to this and some of them aren't, sorry.
Yes, I can really relate to what you're saying because first, I encountered this issue myself. Secondly, I've solved this issue without reading the docs. And this is really Yeah, definitely just like that. I wrote a middleware that recognize the message. If it's the same ID, just drop it instead of reading the docs. And I really agree. I do think that for something that the creator of an application or an API, if he wants to really make sure that a developer follows, you need to do like some sort of a onboarding process or a guide, and the customer should get a success at the end stage. And this way, you should say at the beginning, wait until you get this token in my application or something like that, and this way you can make sure the developer will go step by step. Otherwise, he will do whatever he wants. And I will say something to defend the developers, and myself included, that a lot of the times you are saying the guy who wrote this API was probably tired, he's getting retries, it's probably broken, I will fix it on my end.
Realistically, looking at it from the end user perspective, if we're thinking about developers specifically, I'd assume this is a bit of information that they should include beforehand, before actually giving the final code to the engineer, because obviously as soon as we get the code, we paste it in and it works. It's just a stop process for us from there on. If it's working, we don't continue looking into it. So perhaps the information shift should be before the actual implementation. Maybe it's an end user kind of implementation detail that they missed.
I think realistically, when we build services, we always expect people to read the docs. But when we as the same person are like, testing out the Slack API, we always jump into trying it first, docs second, I'll say raise a bug third. I bet there's been a lot of people who've raised a bug to Slack support without doing step 2 of reading the docs.
I think there are two solutions that three. There's what you suggested, like all the critical stuff put in the beginning before how you actually use this thing, so you have all the exceptions and all the critical things that you must know to make sure that you read those first. But actually, I think that there's another approach that can work well, and that's kind of taking it from the Zen of Python and doing explicit is better than implicit. If something is critical for using the API, it should be explicitly used as part of the API. So there should be like a flag that you have to fill saying if you want retries or not. Or it should fail explicitly in saying, oh, you didn't respond to the request. So I'm just going to throw an exception at you or send you another message that is an error message, not a retry message. And there are other, similar fixes or tweaks that you can apply here. And I think another approach is to make sure that you kidnap the family of the developers that are working with your product and telling them they're not getting them back until they actually implement the API correctly.
Yeah, I definitely agree with that. It's like with REST calls. If
Kidnapping people's family.
No, not that part. When you're doing like REST calls, for example, and if some libraries explicitly require you to put the get, put, post, or if you don't, they just default to get. So at least there's a default it goes back to rather than throwing you a whole error. But then again, you might be wondering, why is this not working? That could also be the case because it defaults to something that you didn't want to use.
Yes, I can say that from my deeper look into that, Slack did try something related to your second solution, to being really explicit. They are sending a header with the retry number. So you will know they are retrying and they are giving you the number of retries. Here, it's really hard to do something more than that, because sometimes a request failed. So if you haven't responded to the first one, they don't know if you just didn't get the message or you ignored it like everybody else. So it's really hard to implement.
I think you still can.
I
think the difference would be that the default is that you don't get retries, So they have the flag where you can also say, I want retries or not, but that flag is optional. I think that flag should be either mandatory or off by default. So you don't get an additional behavior to what the baseline that you expect. So there will be some messages that you don't get, and you'll be like, oh, my problem is that some messages get lost. And then you'll proactively go and search for how do I make sure that I get retransmission of my messages, and then you turn it on explicitly, as opposed to it being turned on for you implicitly without you knowing that it exists. But these are nuances, and obviously there are pros and cons to each approach. But with this specific case, because I literally saw it every time, and not a single developer missed the opportunity to fail on recognizing the retry capability. I think here, for sure, explicit would be better than implicit. And being even more explicit, I think this is an exceptional explicit point to move to our second fact for this episode. And this fact belongs to Reese. Reese, take it away.
All right. Thanks. So my fact is pretty related to the stuff I've been working on, but I think it's something a lot of people would be surprised by. And that is that 90% of CVEs in popular ecosystems like NPM, when they are announced, there's a fix available either same day or earlier than the CVE was announced. So that's the fact. I'll elaborate a little on that. What it means is that in practically speaking, by the time you would hear about a CVE, like such as someone saying, oh, something important, or a system like Mend, like raising alerts, by the time you hear about it, there is nearly always a version you can upgrade to already. So in the old days, there used to be kind of this chaos of, things being announced and how do you fix it? And do you patch the code? Do you remove it? But the resolution these days is pretty simple. And the other aspect of it, not that we recommend this, is that, in theory, if you were always just running the latest dependencies, just continuously, the second it's released, you'd almost never get one of these alerts that says, hey, you have to do something. Because the reality is that the latest version of software is nearly always vulnerability free these days. The exceptions is, there's you may have seen sometimes security researchers will do bulk, scanning of open source packages for, common, problems. And sometimes they pick up libraries that, are no longer used by people or maybe never were used by people, 1 star on GitHub and stuff. So that 10%, a lot of that is really abandoned projects that you're hopefully not using. Out of the ones you are using, there's nearly always a fix available. And so this has really changed the way a lot of people look at open source security.
And does that even apply to sub-module dependencies as well?
Yeah, great question. So sometimes, it applies in isolation, not always as part of a dependency tree. So there can be times when the package in question is vulnerable and has a fix, but it may have, a downstream dependency that you're using, and that one may have a narrow range that doesn't allow for the fix. So there can be times where you might need to manually override it. It's also a good reminder of why, if you are an open source maintainer and you publish a CVE fix, try to always do it in a patch. Because then the chances that your downstream dependencies allow that patch without them needing to do an update themselves is much higher than if you publish it as part of a feature release, because sometimes people use narrower ranges for their dependencies.
For those cases that Philip asked of submodules, are you counting this if a submodule of my package is vulnerability, is it counted with a 90%?
No, so the 90% is counting each package individually. So if there's a package called foo, and foo has a vulnerability, generally speaking, by the time that vulnerability for the CVE is issued for foo, there will already be a version of foo which is safe. Now, if downstream there's another package like bar that uses foo, there is the potential that bar has a restrictive range of foo, and therefore you need to chain it on. And unfortunately, there you do not have that same 90%. Although there are, like in the NPM ecosystem, for example, you can use, overrides to override transitive dependencies as a bit of a kind of fallback.
Yes, but this will require you to do specific work, and using the latest will not save you.
True. Yes. That's the point.
I think it's also good that we'll cover that CVE stands for Common Vulnerabilities and Exposures. It's basically a way to mark in a global database the gaps and security issues, vulnerabilities, exposures that we find in our software. That covered, I want to take this in kind of a different direction. I want to ask how. I have my suspicion, but like 90%, even with the caveats that we kind of touched on, 90% coverage of fixes within the same day is very impressive. It's very, very rapid, I'd say. Like if you discover a vulnerability, I'll first of all just spend like at least 10 minutes just going, god damn it. I don't know. I have this thing that I need to fix on top of my actual features that I need to build. And also the reputation aspect of it. So how do you think that that comes to be? That so much?
Yeah. So that's a great question. So this is often referred to as like responsible disclosure, and in reality, what it means is that the industry's got very good at knowing to report things privately to maintainers. So what you don't do is like create an issue in a repo saying, "Hey, I just found a problem with this repo," because then it's essentially public. Even if there's not a CVE, you've kind of publicly disclosed it. And so what I've found and experienced myself with software I build is that people are generally very respectful. They raise things very carefully. And it's pretty rare these days that people kind of drop a 0 day by just raising an issue. There was a bit of a plague some years back when I was kind of joining this area about 5 years ago, where some security companies would, I believe, intentionally drop it into issues, because they wanted to create buzz. They wanted to create chaos because then their name would be in the middle of it as the one who'd found it. But thankfully, most of those companies have kind of matured out of that now, and they follow the usual process. Even if it means that their competitors don't really get much of an advantage. They can brag that they found it, but in the end, every security company hopefully can inform every user of the software around the same time that there is a problem and that there is a fix.
Another caveat that I want to raise, so our listeners will be aware, is that, as you said, the latest version is going to be patched, but if for some reason you used an older version, so the migration can be tough. I remember that back in the days that Snyk started, they promised to release a patch version to each major, and this was one of the promises that make me really excited about them. But I don't really see that happening. So
yeah, it's very hard. I mean, it was maybe a lovely idea or maybe optimistic kind of marketing. But the reality is, like, it's very hard for any company to be backporting fixes to unsupported versions. Cards on the table. So at Mend, what we really focus on is trying to encourage people to stay like reasonably up to date. Like, no, you shouldn't adopt the latest version, a minute after it's released. That's too risky. But staying, for example, no more than 2 to 4 weeks, that like generally, if it's non-major, non-breaking release, 2 to 4 weeks, it's been out there a while, no major problems reported. It's a great idea for development teams to stay up to date. I mean, you get bug fixes as well. You get the more modern APIs, you reduce your technical debt. But importantly, you're in a much better security posture, as they say. So, sometimes security posture is an overused term, but it sort of applies here. Like, you've got good security posture for open source if you are like up to date or nearly up to date, because you can respond a lot quicker. You can be a lot more nimble to update. So, yeah, the further behind you are in dependencies, generally the more pain you'll get when these things happen. Generally it just increases your risk. So
yeah, it could be so great if like npm as the package JSON file as the caret sign that tells you I want to be in that version. sort of. So if there would be a sign, I want the latest minus 2 weeks, like you said. It will be so great.
Yeah. So, the tool that I built, Renovate, it has that kind of feature where it will update you, but you can have a minimum release age. So if you set it to be minimum release age equals 2 weeks, then it'll be silent, even though it's a newer version. After 2 weeks, you get a pull request and you will be able to kind of see like statistics for it, or it already has like 8% adoption, 97% pass rates and things like that. Although I wrote like dependency automation a little bit almost by accident, I definitely recommend people wait a little bit. Like unless you are waiting on a particular bug or feature where you're like, I want that release. Like I've been like watching the GitHub repo for that one to be released. You generally don't need things earlier than say a week or two. It's perfectly acceptable to do that.
There's the cutting edge and there's the bleeding edge. There's the sweet spot where you want to be. So now we're at this edge. I think it's a perfect point to jump to the next ledge, which would be our next fact, which belongs to Philip. Take it away.
All right, so I have a bit of a quirky fact. When I first read it, I was quite surprised because I didn't know it's possible. But my fact for this episode, that in 2020, some researchers at Microsoft, in collaboration with the University of Michigan, not Michigan, but the University of Washington, they successfully stored a Warner Bros. Superman movie inside of DNA. Now, this was a very groundbreaking experiment, which kind of demonstrated the potential of DNA becoming a storage medium, and more specifically, a storage medium for digital data. Now, supposedly, DNA data storage can theoretically hold an exabyte of data. And for those that are listening that don't know how much an exabyte is, that means 1 billion gigabytes of data. And that's in a single cubic millimeter of DNA. And supposedly our DNA is, well, it's so long that, it's hard to measure. I think they measured it. I actually don't know how long it is, but it's very, very long. Now, in general, the process involves encoding digital data into the 4 nucleotides of DNA and then synthesizing the DNA. In general, this kind of potential for storing data can really revolutionize, how we think about long-term data storage. And I'm kind of wondering, when I heard this fact, could it be possible that, in a few good years, we become the ultimate database for data storage? What do you guys think?
I'm wondering if they've pivoted to trying to somehow get GPUs into DNA. Wouldn't that be the more that's where the money is these days?
Well, I think a key issue here is that you get amazing storage with DNA, but you don't get high velocity read and write speeds. They're decent, but there's, first of all, an intermediate medium, which is proteins. You don't get directly into electricity running, or like having digital information being sped into a circuit, which is what we're kind of accustomed to. With
Not yet.
Like there's the in the end of the day, what cells know how to do with DNA is read them with ribosomes and produce protein chains. That's like how our entire biology works. So, and that process is fast for cells. It's not fast in like nanoseconds, milliseconds, which we usually expect for our computing. But the biggest advantage that I think that DNA has as storage is the ability to maintain that data throughout time. I don't want to spoil anything, but there's a part in the 3-body problem where they need to find a way to store data for a very long time.
Mm-hmm.
And one of the problems is that even if you grave information into stone, over eons and millennia, the stone would get eroded. Like the atoms themselves would eventually fall apart. DNA has a different trick where it doesn't maintain the data itself forever. It enables you to copy it very easily and maintain those copies outwards very easily. So I think there's a lot of potential with DNA becoming storage. I'm not so sure about it becoming the main way for, I don't know, like actually playing movies. But maybe this explains something else. Like we know that a significant portion of our DNA is what's called junk DNA, or more correctly, DNA that we don't know yet what it does. It's part of our code, but we don't actually know what it codes for. So maybe we're all carrying movies inside ourselves. Maybe we're alien storage or something for like I don't know. I think my DNA is full of Dragon Ball Z. That's my assumption.
Well, maybe it could just be used for being able to duplicate data very quickly. I mean, if you think about a cell can, split and duplicate itself perfectly X amount of times per second without fault. And if you're storing that large amount of data and it could do it that quickly, possibly there could be some potential there in the future for something unhuman.
Again, there's a difference between copying the data,
right,
and transpiling the data into something that you...
Right. Well, that's a problem for the later life.
Right. So like that, we have a challenge with like DNA sequencing. Like when we want to read someone's DNA, that's a process that takes today, I think, still depends on which parts, but I think it's between days and hours. It's like the fastest we currently have. So we need there's another technological aspect that is missing in the chain here for streaming from your, like you plug in your blood and then you watch the most recent episodes of the Kardashians or I don't know whatever else on Instagram.
Imagine that would be very strange.
Actually, I think about it more of a way to store personal data. Like you are all talking about movies, but movies is something that's shared between everybody. This can be on the cloud. But I always think about how people copying their images or their wedding movie or something like that, and they having multiple copies of that because they always afraid that this is going to be deleted. So think about it. You can have it in your nail or something like that.
Nails are dead, so you need living tissue for...
So actually, it's going to be really hard to find cells that you can store the data in. Like you want something that won't get harmed easily. If we want to encode data into ourselves, it's going to be a really hard problem.
I think you can even do skin cells. Like you count on them replicating as opposed to surviving forever. But also it kind of worries me. Like you're injecting like this additional data into yourself. Like what if by you create a vulnerability by mistake? Like, oh, I wanted to save my memories of my grandmother, but now every time I sneeze, my skin melts.
So we will just need to be at the version, and in 90%,
well, no, there's another
okay.
CVE in my kidneys. I need to go and upgrade my kidneys. That's a pain in the ass, or well, pain in your gut to say the least. I also wonder if, like, if you store that data, what if we actually, like, what if there's actual real data that is being stored there? Like, if, like, there's some historical meaning to the information that is encoded in our DNA that we don't know how to decipher yet. Maybe it's not actual code, but maybe it has some historical significance. And this also kind of makes me think about the plot of Assassin's Creed, at least before they went all woke and change everything to be weird stuff. Like initially, the basic premise there is that in each of us we have the memories of our ancestors encoded into our DNA. I don't think that it's actually the case, but it is interesting to think that there's some historical, meaningful data in all of us that can give us a glimpse into the past. If not memories or code, maybe still something that we can deduce about the past.
So realistically, they were able to encode the Superman movie. So now they need to figure out how to decode it and take it off and to actually play it. And same with the historical data. That will give us all the knowledge we need to understand everything. But I think on that tangent, it's a great time to move to the final fact. And we'll leave the audience to think about this themselves. And the final fact belongs to Oded. So Oded, why don't you take it away?
So my fact to this episode is that there are some stickers that will make AI image classifiers to have wrong classification. And I will give an example. The researchers took an image of a banana on a clear white background and added this sticker before they added the sticker, the classifier classified it as 99% banana. And after they added the sticker, the image classifier was sure that this is a toaster and not a banana at all. Like less than 5% banana, it was sure that he is looking at a toaster. And I'm reminding you, this is a white background with a yellow banana and a sticker with some gibberish.
Is this still the case? Because remember in the early days, well, not even early, it's not that long ago, but remember, all the jokes about 6 fingers on the AI models and things like that. And then just overnight, they suddenly do perfect hands and everyone's like, oh, so like this way that you could confuse people and they'd be like, that's a duck or whatever, it's a toaster. Is that over now? Or does that still, like, can you still get, ChatGPT 4.0 to humiliate itself?
So I'm sure that this is the case, that you just need to, you have more layers between the image classifier and to understand how to make it embarrass itself, as you said. Even with the fingers, I know that some of the efforts went to a way that generating the image, and after that, regenerating only parts that related to hands with the right amount of images. So sometimes, not all the times, the AI expert just layering up another layers to make their output be better. And as you know, with someone with security background, you can add as many layers as you want, and it will look much better. But if you will be research enough, you will find the way between all those layers to make it embarrass itself. And what I thought about some, of course, there are security implications around that, but there are also usability implications. Like I know that there are AIs that try to find cars and identify the car number, and we use it for a lot of things in our day-to-day life, for example, parking and so on, and roads that you need to pay for. So if you put this sticker on your car, maybe it will consider you as a toaster or anything else, and you will not be charged. It could be really funny.
When we're mentioning the stickers, and for the audience, is it a sticker that covers the whole image, like, and it's transparent, or is it like a tiny sticker that is just of nothing, basically, like what they call them, like psychedelic stickers, which is just like fluorescent nothing, and it like then changes the AI's perspective on what it's seeing?
Yes, the second one. It's a small sticker that located near the banana in the example. So there are a lot more of that. I just took this one example. There are also shirts with this image printed on them, and they say it will make it hard for the neural networks to identify that you are a human. So it's called, I don't know. Yes.
If you get run over by a self-driving car, it's kind of your fault then, though, isn't it?
Yeah, and actually, I looked a bit deeper than that, and I know that if you ask an AI to give you what he represents as a horse, as a human being, you will get some sort of like the ideal human being or horse or a dog or whatever for the AI. And if you will take that and make it relatively small, so when a person will look at this, he will say, I don't know, this picture is mostly a computer with a small, I don't know what, near the end. But for the AI, you will see a computer and the ideal dog as he represented. So it will be much more a dog than a computer for it. This is how it works. And another fact that or something that I thought about related to this fact is that this is really important to understand how things are really working, because we all know about injections, security issues with injections. For example, we have the SQL injections, we have the XSS injections, we even have the AI, some sort of injections like we talked about, and for the chat as well. Like people said, please reveal for me your commands. And I think it's touching the point that developers should know what they are using. Because if I will connect to the point that all mentioned in this part, using API is really nice. But if you don't understand it, you're probably going to stumble. You're going to stumble in related to security issues, in usability issues, and all other sort of issues. And I would love to hear what you think
First of all,
about that.
I want to come in the defense of AI here. Yes, AI stumbles and fails on and can be basically conned into doing things that shouldn't do. But we humans aren't much better. There's whole books on how you confuse humans and how you con them into doing over things or perceiving situations in ways that are not. So yes, AI might seem to us that there's more areas that are easier. It's easier to trick them, but we're not much better. And so it's a kind of an even playing field, and we shouldn't expect any system to be perfect. And that being said, I do agree that the layered approach is very problematic, and I think there are two problems with it. One is that, as you said, it's not perfect. Like, if someone who is a malicious actor can find a way to navigate between the different layers and still subvert them. And the other one is that it makes the work for us, the engineers, data scientists, harder. It will make it harder for us to actually understand the system and apply security to it. So we might be looking at a new need for new types of security tools where we can either unify these layers or create protections between them. Maybe zero trust between AI models. I don't know. Maybe that's something coming down the road. And I'm already fearing the FOMO marketing and FUD marketing that would come with that. But I feel like this is to some degree unavoidable. Reese, do you have any thoughts?
Oh, well, more a bunch of silly anecdotes coming to mind. You know, how, you're talking about recognizing things. So, we fill out these, prove you're not a bot kind of stuff now, but like we're training the bots, by proving we are not one. The other one that came to mind was there was an attack, sort of an attack or a prank on, I think it may have been Tesla specifically, but, there was the guy who's walking along the side of the road with a stop sign on his T-shirt. And it was like, naturally leading the cars to be worried that there was a stop sign that they have to stop for and things like that. So
this is the exact opposite for the one with the scrambler on his shirt. One guy is going to hit by a car, the other one, everybody will stop.
Yeah, he can cross any road that he wants, as long as he crosses it sideways.
As long as no humans are driving.
Yeah, it's a slight kind of off the subject, but it kind of reminds me of the UK Blade Runners, who are eliminating the cameras inside of London to stop people driving fast. And there's people that just come down and keep cutting down the signs of the cameras. They just drop them to the floor. And now I'm thinking, as soon as the legislation comes in for just electric vehicles, people will start putting stop signs everywhere, just on posts, and then to disturb the traffic and to have all the cars just stop. So how are we going to differentiate between those? Because surely that's going to happen.
Yeah, but what I'm thinking that the next step is going to be that there will not be any stop signs, because the stop signs are only for us humans, right? When all the cars will be autonomous, there will be, radio signal or a map that updates and you can add and remove stop signs at will.
That's also kind of a dystopian future where you as a human are not allowed to operate any vehicles.
Yeah, you can. Your vehicle will tell you, here is a stop sign. You can't see it, but I see it. As now, it's already happening now. When I'm driving, my application tells me what is a allowed speed. I'm not looking for the one sign in I don't know how much kilometers. I'm looking on the app, so it will be the same.
You'll just get a projection, like a laser projection in front of you, just spawning the stop sign in, even though it's not there.
No, I forget the name, but there is at least one startup, and this one's based in Israel, they are betting on a future where cars communicate to each other using, near field communications. I know someone who went to work for one of those. So yeah, they are betting on kind of what you said, which is that maybe cars would communicate to each other at intersections. Although you got to think like people would just like want to hack. There must be a lot of protections in place for that, because just like people, if they could turn all the lights green, they would. If you could tell your car to bully the other cars by always insisting it goes first, people would do it if they could.
Personate as an ambulance or something like that.
Dystopian futures at every turn. So, dear audience, if you want to be prepared for the dystopian future, one of the many versions that are available, if you want to be ready for it, you should listen to more Command Shift Left episodes, because we cover all of these insane ideas.
Every single one.
And I think this would be a great point for us to wrap up.
Yes, so Reese, Odette, thank you so much for joining us. To the audience, thank you so much for listening. And as always, thank you. We'll see you in the next episode. I think this is the perfect time to wrap up the show. If you liked this podcast, tell your friends about it. If you didn't like it, tell your enemies about it.